The news last week that a second patient may have been cured of HIV using a bone marrow transplant from a donor with known HIV resistance has brought new attention to a gene mutation that many researchers believe is key to ending the epidemic. The CCR5 delta 32 mutation, which was discovered over 20 years ago, disables the CCR5 receptor on the surface of white blood cells. HIV uses this receptor almost like a key. It latches onto it to get into the cell. Without a working version of CCR5, HIV is essentially locked out of person's immune system. The mutation is most common among people of Northern European descent. Approximately 10% of people in Europe and the United States have inherited this from one of their parents, but it is only protective in the 1% who are homozygotes, meaning they inherited a mutated gene from both of their parents. Studies have shown that these individuals are 100 times less likely to contract HIV. Paula Cannon, Ph.D., a molecular microbiologist who studies HIV at the University of Southern California's Keck School of Medicine, told Wired magazine, "There's a nice menu of things that we could possibly do now. What these two patients have shown us is that attacking the reservoir of infected cells while at the same time providing shiny, new HIV-resistant immune cells can result in a cure." It is also important to note that the CCR5 delta 32 mutation does not protect against all HIV. One patient who had the bone marrow treatment was later found to have a form of HIV called CXCR4 tropic, which uses a different receptor to enter cells. Doctors do not know whether the patient contracted this type of virus after the treatment or whether some patients harbor a small amount of CXCR4 tropic virus that starts to multiply when other types of HIV are not present.